Establishing identities. Whenever you need to establish an identity, you're going to work on one side or the other and try to show or prove that it's equivalent to the other side. When you establish identities, you always want to start with the more complex side first. In this case, we have cosecant of theta times the tangent of theta is equal to the secant of theta. This left side is more complex than the right side. We're going to start with the left side. Cosecant of theta. We know that the cosecant of theta is equivalent to 1 divided by the sine of theta. We also know that tangent of theta is equal to sine of theta divided by cosine of theta. Essentially, when you are solving identities, you sometimes just want to replace things that are there with things that are equivalent to them and see what happens. Here we're going to replace cosecant with 1 over sine of theta. And we're going to replace tangent of theta with sine of theta over cosine of theta. So that's our first step. We're replacing both of those. Then we're multiplying, so multiply straight across. We end up with sine of theta divided by the sine of theta times cosine of theta. The sine of theta has become a giant 1, and we are left with 1 divided by the cosine of theta. Well, 1 divided by the cosine of theta happens to be secant of theta. So through these steps, we have shown or established this identity that the cosecant of theta times the tangent of theta is equal to the secant of theta. Example number 3. Here we have some negative identities. So if we look back over here, those are even and odd identities. Cosine of negative theta or negative a is equal to the cosine of a. Sine of negative a is equal to negative sine of a. So essentially what we're going to do is we're going to replace this. So the sine of negative theta squared plus the cosine of negative theta squared. We want to see, does that equal to 1? We know cosine of negative theta is equal to cosine of theta, and also that the sine of negative theta is equal to negative sine of theta. I'm going to replace sine of negative theta with negative sine theta. I'm also going to replace cosine of negative theta with cosine of theta. When we square a negative times a negative is a positive, so we are left with sine squared of theta plus cosine squared of theta. And we know from our Pythagorean identities that sine squared of theta plus the cosine squared of theta happens to be equal to 1. We've shown that sine squared of negative theta plus the cosine squared of negative theta is in fact equal to 1 through these steps. Example number 4. The left-hand side is the more complex side, so that is going to be the side that we are going to start with. In the numerator and the denominator, let's see, the right-hand side has tangent. We have tangent and cotangent. Since I see lots of tangents and I'm trying to get to tangent, let's try to work towards getting everything in terms of tangent. We know that cotangent of x is equal to 1 over the tangent of x. So we're going to use that to help us. The first thing we're going to do is we're going to place cotangent of x with 1 over the tangent of x. We have 1 plus the tangent of x divided by 1 plus 1 over the tangent of x. Then, now in this denominator, we want to simplify this. So in order to add fractions, they need to have a common denominator. The top is going to stay the same, the numerator will stay the same, so in the denominator we're going to change this to tangent of x over tangent of x plus 1 over the tangent of x. When we do that and we add, we're going to add straight across. So our numerator stays the same, 1 plus the tangent of x, and our denominator becomes the tangent of x plus 1 divided by the tangent of x. Now, we have a division of fractions, essentially. To take care of a division of fractions, we multiply by the denominator's reciprocal. This becomes 1 plus the tangent of x. You could think of it as 1 plus the tangent of x over 1 times the reciprocal of this denominator, the tangent of x divided by 1 plus the tangent of x. Now notice, 1 plus the tangent of x and 1 plus the tangent of x. I switched it, we had it as tangent of x plus 1 up here, but remember addition is associative. It can move around, and it still means the same thing. So if we were to multiply straight across, if you notice, we have 1 plus the tangent of x on the top and the bottom, so those will cancel. And we are therefore left with the tangent of x, which is what we wanted to show.